Easier dealing with double angles than the other angles. A lot easier dealing with double angles. I'm going to go through one identity because I will ask you to do a trig identity problem still. Proving a trig identity with a double angle. It'll be very similar to this. We look at problem number 30. And once again, the identities get a little bit easier. Problem 30, we have the tangent of y is equal to sine 2y over 1 plus cosine of 2y. And we want to get this to equal the tangent of 2y. So once again, you look to see what has more stuff. What has more stuff is the right-hand side. So we make some substitutions. Well, what's the only thing we have for the sine of 2y? Sean, what's the thing we have for the sine of 2y?
2 sine y times cosine y.
That's the only thing we have. Okay, on the bottom, we have 3 different formulas for the cosine of double angles. We want to choose one of them. But we want to choose one that makes it easy on us. Because we want to get to the tangent of y, which is sine over cosine. We got this 1 plus cosine of 2y on the bottom. So it'd be nice if we chose one, and it was smart when we chose one, because let's see what we can cancel out. Can we cancel out the 1? Well, when I cancel out the 1, mathematically, what do we do to cancel out 1? What can we do to cancel out 1? Braden? Subtract 1. Well, does any of our cosine of 2 thetas or 2 a's subtract 1 off of it? Yeah. Should have 2 cosine squared of y minus 1. Now we have a plus 1, we have a minus 1. They go away. We have all multiplication in here now. Canceling anything that we can cancel. Well, the 2's cancel out nicely for us. One of the cosines go away for us also. So cancel out what you need to cancel out. Don't look for me to cancel out. You can do it. You're smart enough mathematically. You should be able to okay, I got like factors, we've been there, done that, I'm gonna cancel them out. We should be left with the sine of y over cosine of y, which is the tangent of y. We is done. You'll have one of the double angle formulas on, or one of the double angles identities on your test. Something like this one or 29. Other than that, the double angle formulas are a lot easier to deal with because, as I talked about before, we've been there, done that. You're applying formulas. You're doing the exact same thing as you did before. The worksheet that we come back around to on Wednesday with the in-class assignment, we'll be utilizing these ideas. Today we're going to work with half angles, double angles. Now we're going to deal with half angles. But what we're going to utilize, we're going to use the double angle formulas for our half angles. We had 3 different formulas for the double angle for cosine. Three formulas that dealt with your double angle for the cosine. One of them was the cosine of 2a is equal to 2 cosine squared a minus 1. That's what we just utilized also. To develop our half angle formulas, what we're going to do is we're going to let a equal x, or half of x, where x is any angle. X is any angle. So if I take half of x, I'm taking a half of that angle, whatever that angle is. And I'm going to make a substitution. So wherever I see an a, I'm going to put in a half x. So we have the cosine of 2 times x over 2 equals 2 cosine squared x over 2 minus 1. So wherever I see an a, I'm putting in half x. Well, if I multiply 2 times 1/2, 2 times a half x, what do we come up with, Isaac? Oops. 2 times half x, what do I get? What happens to our 2's? Huh? They disappear, they go away, so we're just left with, what did you say? X. So we're left with x. Is equal to 2 cosine squared of x over 2 minus 1. Adding 1 to both sides. We have 1 plus cosine of x is equal to 2 cosine squared of x over 2. Just adding 1 to both sides. We have multiplication by 2. We can divide both sides by 2. These go away. So I'm just going to rewrite this as cosine squared of x over 2 is equal to 1 plus cosine of x divided by 2. And then our last step is to get rid of a square. We take the square root. And what we are left with is a cosine of x over 2, which is the half angle, or you can write that as 1/2 x. Does not matter. Is equal to plus or minus square root of 1 plus cosine of x divided by 2. And there's our half angle formula for cosine. Plus or minus square root, 1 plus cosine of x divided by 2. Once again, we continue to add to what we've done. Likewise, if we take another one of our double angle formulas for the cosine, We have cosine of 2x, or 2a is equal to 1 minus 2 sine squared of a. And do the exact same thing. Just substitute in the x over 2 for a. So we have the cosine of 2 x over 2 is equal to 1 minus 2 sine squared x over 2. Now, for this one, we're going to do what, once again, mathematically I call the double switcheroonie. The reason why is I want to get my coefficient here to be positive. So I'm going to add this to both sides. And I'm going to subtract off the cosine of x. So what we're left with is 2 sine squared x over 2 is equal to 1 minus cosine of x. Once again, it just makes my coefficient positive. Makes it a little bit easier. We can divide both sides by 2 again. So we have the sine squared x over 2 is equal to 1 minus cosine of x divided by 2. And then taking the square root from both sides again, we're left with the sine of x over 2, which is your half angle, plus or minus square root 1 minus cosine of x divided by 2. Looks very similar to your cosine of half angle, except for negative and positive here. They're the exact same formula, just one's plus cosine, one's minus cosine. That is your cosine, your sine of your half angle formula. Your tangent of half angle will give us 3 formulas, just like the cosine of a double angle. We'll get 3 formulas here. Your cosine of x over 2, your tangent of x over 2 is equal to sine over cosine of half angles. So if we take a look, this is plus minus square root 1 minus cosine of x divided by 2 over plus minus square root 1 plus cosine of x over 2. Since we're dealing with division here and we have complex fractions, we can multiply top and bottom by square root of 2, and these will go away. So we are left with then plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. Now there's two alternate formulas to go with this. If we multiply top and bottom by 1 minus or 1 plus cosine of x. Okay, we're multiplying by a value 1 because we're multiplying top and bottom by the exact same thing. What we are left with on top is the square root of 1 minus cosine squared of x over 1 plus cosine of x squared. If I would FOIL out 1 minus cosine of x times 1 plus cosine of x. This is a difference of perfect squares multiplication, where we'd have 1 plus cosine of x minus cosine of x minus cosine squared of x. Just a difference of perfect squares. These cosines of x is in the middle, they go bye-bye. So we have 1 minus cosine squared. Now if we think back to 1 minus cosine squared, what's 1 minus cosine squared equal? Anybody remember what 1 minus cosine squared is equal to? What's a substitution that we can do? Sine squared. Very good. So we're left with the square root of sine squared of x over 1 plus cosine of x squared. Both of these terms are being squared. So what we are left with is the sine of x over 1 plus cosine of x. So your double angle formula can be reduced to sine of x over 1 plus cosine of x. We can do the same by multiplying by 1 minus cosine of x, 1 minus cosine of x, top and bottom, and it's going to look very similar to what we had, but what this will come out to be is 1 minus cosine of x over sine of x. So you have three different formulas for the tangent of half x. Three different formulas for the tangent of half x. I will not ask you to do any trig identities with the half angles, but we will have applications of the half angle formulas. Cosine of theta is negative 3/5. Theta is in between 90 and 180 degrees. So if theta is between 90 and 180 degrees, Bennett, which quadrant would that be in? If you're between 90 and 180, which quadrant would that be in?
4 and 3.
4 and 3?
2.
2? I'm going between 90 and 180 degrees. Which quadrant is the angle between, or has angles between 90 and 180 degrees?
2.
Quadrant number 2, that is correct. Because we go from 0 to 90 to 180. This is 90 degrees of rotation, this is 180 degrees. So in quadrant number 2, I'm drawing my angle. Here's my angle theta. Here's my angle theta reference. And as we've talked about, time and time again, the cosine of the angle theta is equal to the cosine of angle theta reference. So within that triangle, I want to make the cosine -3/5. So put your values in there. What goes where? The cosine of that angle is -3/5. Cosine is defined to us. Hopefully we know this by now. Adjacent over hypotenuse. Use your good old buddy Pythagoras to find the third side. Cadence, what's going to go where?
-3 is adjacent, and then 5 is at hypotenuse.
And what's fourth side?
4.
Or the other side, 4. Okay, I need to check to make sure negatives here. Well, this one's going to the left, so that's negative. I'm okay there. This one's going up, don't need it. This one's hypotenuse, don't need it. I want to calculate the sine of theta over 2, half theta. Well, sine of half theta is defined to us as plus or minus square root 1 minus cosine of theta divided by 2. Once again, this is where your calculator will help you out. Or, once again, as you develop your math skills, hopefully your development of math skills, you should be able to work yourself through this. Cosine of theta, well, it's already given to us as -3/5. So I'm going to sub in 1 minus a -3/5 divided by 2. We have minus a negative. Hopefully we know by now minus a negative we will get a positive. They will cancel out. If we multiply top and bottom by 5, we need to make sure we distribute. So we have 5 plus 3 on top. We have 10 on the bottom. We have 8 over 10, which hopefully we know reduces down to 4 over 5. Which, using our properties of radicals, we should have learned in algebra, this is square root of 4 over square root of 5. Now, once again, if you click into your calculator, 1 plus, you don't even have to put a plus in there, but if you quantify 1 plus 3/5 and your quantity divided by 2, hit your math button, hit enter, hit enter. It will come down to your 4/5 for you. So once again, if you click in your calculator, 1 plus quantity, 1 plus 3/5, and your quantity, divide by 2, hit your math button, hit enter, it will come back to your 4/5. Once again, if you want to advance yourself with your mathematics, you multiply through by your 5 there, top and bottom, and reduce down. Okay, square root of 4 we can do, that gives me 2, but square root of 5 we can't do, so to rationalize this, Bailey, what do we got to use? Multiply to do, Bailey, how about Brianna? Sorry about that. What we got to multiply top and bottom by to rationalize this? My bad, sorry about that. So we're left with plus or minus 2 square root of 5 over 5. That's the old man brain. Now the question is, which one is it? Is it plus or minus? We have to choose. if theta is between 90 and 180 degrees, half of theta has to be in between what two values? Mel? What do you think? If theta is between 90 and 180, half of theta is going to be in between what and what?
180 and 270.
180 and 270. How'd you get 180 and 270?
Because it's the next quadrant.
Next quadrant. Grace, what do you think? Well, think about this. Theta is between 90 and 180. Half of theta is going to be in between what and what? Trent?
0 and 90.
Not quite 0. Not 90 and 180. 45 and 90. How'd you get 45 and 90? Yeah. If I divide theta by 2, using my multiplication property of inequality or division property, if I divided this by 2, if I divide this by 2 and this by 2, I get 45 and 90. What I want you to do is pick any number that you want to pick between 45 and 90. And take the sign of that value. Make sure you're in a degree mode. Is it a positive or negative quantity? Positive. So my solution here is going to be a positive then. Cosine theta divided by 2. Once again, application 1 plus cosine theta divided by 2. It's going to look very similar, except for now I got, rather than boom changing that negative out of there, I'm just going to say 3 plus a negative 3/5 divided by 2. Do they follow whatever process you did? Follow the exact same process, except for I don't have minus a negative here anymore. And simplify it down. Check your interest, somebody around you. And then check your, choose your positive or negative, which ones are going to be. Pick any angle cosine between 45 and any angle, take the cosine between 45 and 90. Todd, what do you come up with?
I'm not there yet.
Lexi, what do you come up with?
Positive square root of 5 over 5.
That's correct. It should come down to 2 over 10. 2 over 10, which reduces down to 1/5. 2/10 reduced down to 1/5, which is square root of 1 over square root of 5. Multiplying top and bottom by square root of 5. We have square root of 5 over 5. And I take the cosine of any angle in there. I should be positive. Now the nice thing about the tangent, if you use one without the radical there, if you use the one without the radical, you don't have to worry about choosing plus or minus. My favorite, the one I use, is the one minus cosine theta over the sine of theta is the one I typically use. The 1 minus cosine over sine. Reason why is if I get some sort of radical in the bottom, I don't have to use a conjugate to multiply it out. It makes it a little bit easier. I can just multiply top and bottom by whatever the radical is. So we have 1 minus cosine of theta over sine of theta. And the sine of theta is 4 over 5. But if you use the other formulas, you'll come down to the same solutions here. We can either multiply by 5 or you can quantify both top and bottom. Hit your math button, hit enter, and it will take you to your answer. Once again, if you quantify the top and bottom and just type in 1 minus negative 3 divided by 5, and your quantity divided by quantity 4 divided by 5, and your quantity, hit your math button, hit enter, you'll get your answer. Grace, what do you come up with?
8 over 4, which is
2. And once again, if I use the other one, sine of theta over 1 plus cosine of theta, you'll get the same answer. If you use your square roots, that's fine, but then you're going to have to choose which one, positive or negative. That's why I like using this one. And once again, if somehow there's a radical that gets thrown into the bottom, makes it a little bit easier to rationalize if I don't have to worry about the conjugate. Homework's on page, I don't know, I can't see that far anymore. Tomatoes. 133, 138, 139, 5 to 24 multiples of 3. Five to 24 multiples of 3, or 15 to 24 multiples of 3. We're solving some equations in there, and applying the formulas. Once again, as we go through these, hopefully you see a lot of similarities in the problems that we're dealing with here. It seems to be the same types of problems over and over again. What I will give you on a test, when you have a quiz, I'll just give you 2 angles and 2 quadrants, and have you apply double angles, half angles, and sums and products formulas, which we'll go over tomorrow. The goal is to have a quiz on Friday. I may shove that to Tuesday. I don't know, we'll see how things go this week. Adios, have a good day.